All right, the next step on this fun journey is the chain rule, which describes what happens when we have the derivative of a composition of functions. And so, without giving away the spoiler here, let's see what this thing out to be in practice. Well, it would be the evaluation fg of x plus h minus f of g of x all over h. And so I'm going to do something a little bit tricky here. It's a similar trick to what we did before. When we derived the product rule, I decided to add 0 to something like this. I'm going to do something equally useless, which is multiply by 1. So what I'm doing here is multiplying by this expression here. And by rearranging uh, the denominators here, what I get is the limit as h approaches 0 of f of g of x plus h minus f of g of x over g of x plus h minus g of x times g of x plus h. I'm going to switch to blue. G of x plus h minus g of x over h. Now, first things first, just like before, as per any limit thing, if I have a limit here, h goes to 0, I have a product of two things here, I can say that is the product of the limits. So I can separate that out. And this thing is g prime of x. So we know that's going to be a part of our solution here. Looking at this thing though, it's harder to evaluate what that is. I'd like it to look more like this. So I'm going to introduce a new character to this game, and I'm going to call k equal to g of x plus h minus g of x. And what that also means is that g of x plus h is g of x plus k. I'm just going to use k as a placeholder to represent that difference. So what that does to my expression here, though, is I get to say that that's k, and that's g of x plus k. And as h goes to 0, this difference here goes to 0, right? If that goes to 0, I just get g of x minus g of x, which is also 0. So when h goes to 0, k goes to 0. And this thing gives me a whole new limit, and I get to say that this thing is f prime, but instead of at x here, I have g of x plus k, I get f prime of g of x times g prime of x. And that is what we call the chain rule. All right. So to see this in practice, let's ask ourselves, what is the derivative of the square root of x squared plus 1? Well, we first probably want to note that that is x squared plus 1 to the minus 1 half. Or sorry, just to the 1 half. And so if I'm evaluating that, then I need to see this as a composition of functions. And so what I see is that there's a g of x on the inside, and there's an f of x, which is square root of x on the outside, the x squared plus 1 lives inside the square root of x. So parenthetically, if f of x is x to the 1/2 and g of x is x squared plus 1, then f prime of x is 1/2 x to the negative 1/2, and g prime of x is just 2x. So with that said, when I apply the chain rule here, what I get is 1/2 x squared plus 1 to the negative 1/2 times, so that this is my f prime at g, right? I'm plugging g into f prime, g f prime times 2x, that's my g prime of x. And then there's stuff you can do. You can cancel the 2 and the 1/2 and all that. So maybe let's do one more example. Let's look at the derivative of e to the minus x squared. So again, I have to look at this as a composition of functions. So it seems like the minus x squared is my g, and that lives inside exponentiation by e, which will be my f. So if f of x is e to the x, and g of x is minus x squared, f prime of x is still e to the x, and g prime of x is minus 2x. So if I were to evaluate that out, I would get f evaluated at g, sorry, f prime evaluated at g, so that's f prime of g, times g prime. And that gives us our derivative here. Thank you.